students. My name is Chaitanya, Physics faculty at Shakthi International School. Today, in this video, we are going to learn about an important topic from chapter Ray Optics of class 12. Okay, the topic that we are going to see is deviation of light ray due to a glass prism. Glass prism. Okay, this is a concept that we have to see. In this first thing, you have to understand what is a prism. Prism is a transparent solid surface, solid medium, in which you will have two triangular faces, like this, and three rectangular faces. So three rectangular faces and two triangular faces we will have. Okay, this is what a prism is. It is a continuous, okay, solid transparent material, transparent medium. Okay, now if we are allowing a light to pass through it, let's say we are seeing it from the top view. This is the top view we are seeing. Let's say if I am drawing that top view, I can draw it like this. This is the shape of the prism that I will be getting. Okay, now this is called angle of the prism. A is called angle of prism. Angle of prism is nothing but angle between two refracting surfaces which are involved in the refraction. Okay, now let's say we are allowing a light ray to fall on this surface at this particular point. Okay, so this is the point where light ray is being incident. Now we have to draw a normal in order to understand the angle of incidence. So when we are drawing a normal, that normal will make 90 degrees angle. One second, let me draw it clearly. Yeah, now let's say this is a point where light ray is being incident. I have to draw a normal. This is the normal which is making 90 degrees angle here. Okay, so this will be my angle of incidence. Instead of light ray going in this direction, it will bend towards the normal. Why it is bending towards the normal? This is your air medium, this is your glass. So obviously you know refractive index of glass is greater than refractive index of air, right? Obviously when density is more, light ray will bend. When light ray is moving from denser medium to rarer medium, it will move away from the normal. When it is moving from rarer to denser, it will move towards the normal. So this is the path in which light ray will go and strikes this surface. At this point I have to draw a normal again. Now that normal will be making an angle of 90 degrees again here. So now instead of going straight in this path, the light ray will be bending away from the normal. Since it is moving from denser medium to a rarer medium, it is going to move away from the normal now. So this is your angle of emergence. This is the angle of incidence. This is the angle of emergence. Now this angle we are taking it as angle of refraction R1. Let's say this angle is R2. So we are concentrating, we have to concentrate on three important figures. Like we are having one trapezium, okay, which is in this format. We are having one triangle, which is in this format. We are having another triangle. If you are extending this is what the angle of deviation is. This is what your angle of deviation is. Change in the direction of initial path. Okay, angle of deviation is nothing but the angle with which the initial path has changed into the final. Okay, So we are taking another right angle triangle, another triangle in this format. Okay. So this is the initial path. This is the final path in which it is actually going. We are drawing the same conditions here. Now, this is your angle of deviation we are taking. Now, if you are observing it, this is your angle of the prism A. The angle here is going to be 90, and this angle is also going to be 90 because these are angles made by normal. And in this triangle, this is your R1, this is your R2. If those two are R1 and R2, this angle is 180 minus of R1 plus R2. The same you can write it here also because that is the angle 180 minus of R1 plus R2. And in this right angle triangle, in this triangle, if you are observing, we know the angle made by, okay, if you are drawing a normal here, okay, if there is a light ray, this is how it is coming, this is how it is going. If you are drawing a normal, we have written that this angle as angle of incidence, and if the normal is drawn here, this angle as angle of emergence. We know the angle from here to here is what, angle R1, and the angle from here to here is angle R2, right? That means this entire angle from here to here can be written as I minus R1, and this angle from here to here can be written as E minus R2. Since this entire angle from here to here is alternate angle, okay, opposite angles, this is also going to be I. So the remaining angle, if you want to write only this, you can write it as I minus R1, and this angle also the same. You can write this smallest angle from here to here as E minus R2. Now further, if you are redrawing that, okay, this is I minus R1, and this is E minus R2, and this is your angle of deviation. You know from the general concepts of triangle, the sum of the two internal angles is equal to the third external angle. So dou deviation dou can be written as I minus R1 plus E minus R2. Okay, from this equation, from this trapezium, we can write total angle of the trapezium should be 360. So A plus 90 plus 90 plus 180 minus of R1 plus R2 is equal to 360. So these angles get cancelled. You can write A is equal to R1 plus R2. This is one important conclusion that you got. The next important conclusion can be written in terms of deviation. I plus E minus of R1 plus R2. Further, you can write the deviation as I plus E minus, in place of R1 plus R2, I can substitute A. This is another formula for deviation. Okay. Now, if you observe in this entire prism, in this prism concept, we are having two refractions which are happening. First is when light ray is entering from first medium to second medium, and the second when the light ray is entering from second medium to first medium. So two refractions. We know refractive index of the glass, we know refractive index of air. If you are using Snell's law for the first surface, Snell's law states that refractive index into sine of angle in that particular medium is equal to refractive index into sine of angle in that particular medium. Okay, this is for first surface. If you are doing the same for the second surface, refractive index into sine of angle in that in that medium to refractive index A into sine of angle in that particular medium, NE. So you know you can write Ng by Na. Refractive index of glass with respect to air can be written as sine E divided by sine R2. And in the same way, from this expression, you can write refractive index of glass with respect to refractive index of air can be written as sine of angle of incidence I divided by sine R1. Now we know refractive index of glass is always going to be constant. That means I can equate sine I divided by sine R1 equal to sine E divided by sine R2. If this is a condition, if we are having a condition, if R1 is equal to R2, that implies angle I will be equal to angle E, and the deviation that you are going to get will be a minimum deviation. This is experimentally found. Okay, the deviation will become minimum. In general, what is an equation for deviation? I plus E minus A. If R1 and R2 are equal to R, You can write A is equal to R1 plus R2. You can write the same as 2R equal to A. So that means angle of refraction can be written as A by 2. This is one formula. Now the angle of minimum deviation, I plus E minus A. You can write I and E both are equal. So 2I minus A can be written here. So this is the angle of minimum deviation. From this condition, if let's say we are trying to find what is the angle of incidence. Okay, what is the angle of incidence if you are trying to analyze? So dou minimum plus A by 2 will be equal to the angle of incidence. Now why we are actually analyzing these two? In some problems, they will give you to find refractive index of glass with respect to air. We know that it is sin I divided by sin R1. Okay, we can write it like this. From in that condition, you can write Ng by Na as sin I given if it is minimum deviation, dou minimum plus A divided by 2 divided by sin of, in place of R1 I can write it as A by 2. So you can find the refractive index of glass also by using this deviations formula. Okay, this is what happens, how light is actually bending towards the normal. Okay, so what is happening in the prism we have seen. I hope you understood this topic well. Okay, we'll meet in the next video. Thank you.